Today we're going to start looking at what happens when you change the slope of your line or if you change the y-intercept of your line. So what we're looking at is really what we call families of lines, what the changes will do depending on what you decide to change. So the first thing we really have to learn about is what's called the parent function. So our linear parent function is y equals x. So look at that right here. That's our linear parent function. Parent function is a word that we're going to use, or phrase we're going to use all the time. I promise you will see this on district checkpoints, campus checkpoints, and definitely on the STAR test. Every year on the STAR test, they ask questions involving the parent function. And normally what they're asking is for you to compare some line to the parent function and state what has changed. So that's what we're going to practice on today. So if you'll look at this graph, what we've got is the parent function is graphed right here. Y equals x. Y equals x meaning there's no intercept. It goes through 0, 0. And the slope, 1x, would be 1 over 1. So it's going up 1 over 1 the whole time. So that's our parent function. So on the same grid, we're going to graph two different graphs. First one we're going to graph is y equals 2x. So let's look at the information we need on y equals 2x. We know that our our slope, is going to be 2, and our y-intercept is going to be 0. So I'm going to go ahead and I'm going to start at 0. And I'm going to put my dot. Let's go ahead and make this a little bigger so we can see it. Okay, so I've got my dot at the y-intercept, and then my slope was 2. So if I have an ilm of 2, let's just write this over here. If I've got an ilm equals 2, then my rise is 2. I have to turn it back into a fraction. The only way to turn a whole number back into a fraction and keep it the same is to put it over 1. So I'm going to go up 2 over 1 and put a dot. I'm going to do it again. I'm going to go up 2 over 1 and put a dot. I'm going to go up 2 over 1 and put a dot. Up 2 over 1, put a dot. Now I'm going to do the opposite. I'm going to start back at my origin. I'm going to go down 2, backwards 1, and put a dot. Down 2, backwards 1, put a dot. Down 2, backwards 1, put a dot. And pretty soon, I've got my line drawn. That's my red line, which is y equals 2x. And I'm going to go ahead and connect it. Okay. Now let's look at the second graph that we're being asked to do. And it's y equals 1/2 x. So first thing I'm going to do is just figure out my ilm and my b. So my ilm on this thing equals 1/2, which is already written for us in the rise over run. And my b, again, I don't have a b over here, so it's 0. So let's go and graph that. Oops. Okay, so it says that my b is 0, so I'm going to start my graph at 0 again. And this time I'm going to rise 1, run 2, and put a dot. Rise 1, run 2, put a dot. Rise 1, run 2, put a dot. And then I'm going to go backwards. Go down 1 and backwards 2 and put a dot. Down 1 and backwards 2. Put a dot. Down 1 and backwards 2. And now I'm going to go ahead and connect my line. Okay, and that gives me a very colorful representation of what we're dealing with. So let's look at this. So the first question it's asking is, how did that 2 change my parent graph? So we're talking about the red graph. And it's asking, how did the slope of 2 change my parent graph? So let's remember, my parent graph is this dotted line that was given to us, which we know that the parent graph has a slope of 1. So what happened when my slope went from 1 to 2? Well, as my slope got bigger, my line got steeper. So I'm going to go ahead and put that. The line got steeper. And then it's asking, well, then how did the 1/2 change the graph? So if you can remember, the 1/2 was our blue line. So our parent function has got a slope of 1. Our blue line has a slope of 1/2. 1/2 is getting smaller. 1/2 is smaller than 1. It's getting closer to 0. And notice how our line is getting flatter. It's getting flatter and flatter, like it wants to lay down. So our answer is the line got, what's an N? Flatter. Sometimes they'll use the word shallower. My line got shallower. So these are actually vocabulary words for you. You need to know when a line looks steeper. Steeper is, it would be harder to ride your bike up a steeper hill. The steeper the hill is, the harder it is to walk up or ride your bike up. When it's talking about flatter, flatter means, you know how you lie flat in a bed, it's getting closer and closer to just being no line at all, lying flat, a 0 slope. Okay, so based on that, if you notice, our B never changed. We always had a B of 0. So all of these lines, this family of lines, all we were looking at was what happens when we change the slope. Well, as the slope got bigger, so that's our red line, as the slope got bigger, our line got steeper. And as our slope got smaller, our line got flatter, got closer to laying down to 0. So the role of the M is to change steepness or flatness. That's the only role of the M. Notice that the M did not make any change on our y-intercept. Y-intercept has a totally different job. Okay, so let's look at what happens when our slope becomes negative. So let's look at number 2. So number 2, again, they've graphed the parent function for us. This time they're going to ask us to graph 3 different lines. The first line they're going to ask us to graph is y equals negative x. So I'm going to do that in a weird peach color. Okay, so y equals negative x. My M is going to be -1, and my B is 0. Okay, so I'm going to go ahead and I'm going to start at my y-intercept of 0, and I'm going to put a dot. Then my B is, or my M, my slope is -1. So to turn that into a fraction, I'm going to make it -1/1. So down 1, run to the right 1. Down 1, run to the right 1. Down 1, and I'm going down first because it's negative, but I'm still running to the right. Now, if I want to go backwards, I'll go up 1, but now I'm going to have to run backwards to the left. Okay, and let's go ahead, and we're just going to leave this one as a dotted line. Notice the difference between my parent function, y equals x, and this function, y equals -x. They have the exact same slope, except that one is a +1 slope and one is a -1 slope. But they're the same up 1 over 1 ratio. Okay, so now let's look at graphing y equals -2x. So our slope, oops, don't want to do that. So my slope on this, let's make this a much smaller line. Our slope is -2. My y-intercept is still 0. So how do I change that -2 into a rise over run? That's going to be -2 over 1. Okay, so let's go ahead and graph this. I'm going to start again at the B, which is 0. So I'm going to put my dot at the 0 again. This time, -2 over 1 is the slope that I'm graphing. So negative means I go down first. So I'm going to go down 2, over to the right 1, and put a dot. Down 2, over to the right 1, put a dot. Notice that we always run to the right. The only thing that changes is if we go up first or down first. With a negative, we always go down first. So down 2 over 1 dot, down 2 over 1 dot, down 2 over 1 dot. Now we're going to go backwards. So this time up 2, backwards 1, up 2, backwards 1, up 2, backwards 1, up 2, backwards 1, and now I have a line. Okay, now let's do our very last one. Our last one is giving us a slope of -1/2 x. Now based on what you've already seen in the positives, do you think our 1/2 x is going to be a steeper line or a flatter line? Well, it's getting closer to 0, so let's see what happens. We have an m of -1/2. We have a b of 0. So again, I'm going to start my graph on the b. I'm going to put my dot here on the b. -1/2. So negative, I'm going to go down first, and then to the right 2. So down 1, to the right 2, put a dot. Down 1, to the right 2, put a dot. Down 1, to the right 2, put a dot. And keep that going. Now we're going to go backwards. So up 1, backwards 2, put a dot. 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 And now we have our blue line. So now let's answer the questions. What happened when we went from a positive slope number to a negative slope number? Well, it changed our lines to negatives. Okay, so then let's look at how the -2, impacted this graph. So on our positive graph, the -2 made the line steeper. Well, notice also on our negative graph, the negative is making our line steeper. If you were to ride your bike down this hill, there's a good chance you're going to crash and burn because it would be going so incredibly fast. It's a very steep hill. So we're going to put makes line steeper. Oops. Let's put that in red because it's a red line. So makes line steeper. Okay, and then it asks about the -1/2. Well, again, 1/2 is starting to get closer to 0. As it gets closer to 0, it's closer to laying down. So the -1/2 makes our line, our blue line, is flatter. Okay, so the role of m, just like in a positive line, the role of m in a negative line is to change the steepness or the flatness of our line. Okay, so now let's look at our next family of lines. And this one, we're still starting off with our parent function. Our parent function is y equals x. It's already been graphed. But now we are going to graph two new lines. We're going to graph y equals x plus 3 and y equals x minus 3. So I'm going to start with my slope, x plus 3. My slope is just plain old 1. And then when I have x minus 3, my slope will still be 1. Okay, so my slope is 1. Now we have a y-intercept. So my y-intercept is 3. So let's graph this. Okay, we're going to make this line red. So my y-intercept is 3. So I'm going to go up to the 3, and I'm going to put a dot. There we go. Got a dot on the 3. Now, my slope is 1. So I'm going to go up 1 over 1, put a dot. I'm going to make this bigger so I can see this. Going to go up 1 over 1, put a dot. Up 1 over 1, put a dot. Up 1 over 1, put a dot. And I'm just going to go keep putting my dots. Okay. So now if we look at this, I'm going to go ahead and connect all my dots. And we've got our first line. I'm going to go ahead and circle it in blue so we know that this is our blue line. At least so I can see it. Okay, so that's my blue line. Now let's do the red one. So this one, we're going to need to write it out again. We've got an m of 1 and a b this time equals -3. So let's go back over to our graph, make it bigger, and let's graph this. We got a starting point of -3, so I'm going to go 1, 2, 3 and put a dot. Then I got a slope of up 1 and over 1. So I'm just going to go up 1 over 1, and down 1, backwards 1, put all my dots, and connect my line. Okay, what do you notice about these 3 lines? Well, they're parallel. And if they're parallel, what is it that's the exact same about the parent function and the 2 lines I've just drawn? Well, the exact same thing would be our slope. So notice we had a slope of 1 here, a slope of 1 here, and then my parent function had a slope of 1. So the slope didn't change, therefore my lines were all parallel. But what did change? Well, on my blue graph, I had a y-intercept of +3. What did that do to my line from the parent function? Well, it shifted it up. So it shifted it up 3 units. And then let's look at the red line. What did that -3 for my y-intercept do to my red line? Well, it shifted it down. So then the overriding question is, what is the role of b? What is the role of my y-intercept? Notice it made no change at all to the slope of my line. My line isn't steeper or flatter. The line is the exact same. All that b did was shift or translate. That's the other word you'll see all the time. Shift or translate the line up or down. So let's turn to the next page. See, on this page is, based on what we just learned, let's make a couple of predictions. So what I want you to do is I want you to look at number 4 on your own, make a prediction, fill it out, and do that for number 4, 5, 6. Now just do it for number 4 and number 5. Make a prediction and then check back and see what your answers are. Okay, for the first one, translation up and down. This is if it's moving up and down the y-axis. So we got to first look at our b. So if we look at our b on this, our b is the one without the x. That would be -4. -4 means we're starting lower than 0. So we translate down, and then we have to look at our slope. Our slope is a positive 3. Positive means it'll be a positive slope. And then the 3 is bigger than 1, which is our parent function, so it's going to get steeper. Okay, on the second one, again, we're going to look at the b first. Our b is the one without the x value. The b is positive, so we're translating up. Then we're going to look at the slope, because the last two questions are asking about slope. I have a slope of 3/2. That's a positive 3/2. I have a positive slope. The question is 3/2 bigger than 1? Well, 3/2 reduces down to 1.5 or simplifies to 1.5, so it's again steeper. Okay, for number 6 and number 7, you can't answer them until they're simplified and in the y equals, or the slope-intercept format. So on number 6, you're going to have to distribute first, and on number 7, you're going to have to solve for y first. So go ahead, pause the video, do both of those, and then come back and check your answers. Okay, look and make sure that you solved for y correctly, and check your answers. Now, on the rest of these, number 4, 5, 6, 7, 8, and 9, and 10, just go ahead. These are what you're going to see on tests. So pause your video, answer all these, come back and check your answers, and then we'll keep practicing it during class. Okay, so quickly check your answers over this. You can pause it to verify, and then we'll see you in class.